Fine. So now the most important graph I wanted to demonstrate is the slope graph. So here I'm going to show you different types of slope graphs, and then there was a practice task which was based on the simulated data, and then so you can also explore that. So I just want you to know that when you have a repeated measures data, or data where the variables were collected at multiple time points, and you want to investigate the change, and even you want to investigate the change and stratify it based on some specific categorical variables, you can add all these complications in your visualization. So here, the goal was that there was a variable called change in S protein. This VSAB is S proteins. You don't need to understand that. Yeah, fine. And I wanted to explore the change, but keep in mind that the data was such that they collected the data at a certain time point, and then they collected the same data at another time point. So the change is just the difference, isn't it? But here, instead of the change, instead of the percentage change, I was looking at annualized percentage change. It's fine. It's just the change in percentage form, fine. And the change could be negative or positive depending on whether the value at the current time point was less or greater than at the baseline time point, fine. So here, this is so it means that if you want to do the slope graph, the first thing is that the variable, which is, let's say, the change you want to investigate, should be, you don't have to have the change for the first time point and the change for the second time point separately. You should combine them into the same data, right? So what I mean is that it should be the same data where the first half of the data is for the data for the first time point, and the second half is the data for this the data for the current time point. So, and that is what I was trying to achieve here. So this is basically what I was trying to achieve, and I was extracting the specific variables of interest, the variables I was interested in investigating. So here it's not necessarily this change that I'm trying to look at, but since I have I was trying to look at this particular variable V2SAB, and then and then this data has been collected at 2 time points, and I wanted to investigate the change graphically. So just coming down. So it means that you can have this kind of plot where you want to track each individual. So let's say the data, you have specific IDs of the individual, and you want to track each individual. So it means this one, it tells me that this particular individual, there was a decline in their score in terms of the S protein. As you can clearly see, there's a decline, and you're able to track that. Yeah, but for publication purposes, you might not want to create this kind of data. Okay, this is just when you are trying to show to a certain team, because if it is quite a complex data where we have so many participants or so many rows, this can look quite clumsy. So it means that most of the times we just want to have a fair idea about the pattern in the data. That's the most important thing. But this is when we want to track each individual. This is how we go about it. And then, but this is my preferred plot. So now coming down here, so you can now get this kind of plot. So where, so it means the red bits are the data at, let's say, the first time point, and the green bits are the data at the second time point. So it means that this particular individual, the data at the next time point is this one, and so this maps. So the moment you map that to the other data, it just tells whether there was a decline or there was increase. Okay, so this is some of the ways you can visualize data that were repeated measures data or had multiple data points. So this is just one of those instances. So what is up here, I wouldn't add, I mean, it depends if you fancy it, but personally, I wouldn't want to indicate the IDs. I just want to have the data in this form, and then I'm able to tell the patterns in there. And then now let's look at a more complicated way of investigating this slope graph. So here you go through, you run these codes. These are automated codes, so you'll be fine. So you run, so I'm just trying to show you the plot. You can go through the details. We don't have much time. So in R, if you want to test normality, we use this is the Shaprobok test. Keep in mind that if the data is very large, chaperone test will fail because in R it can do up to 5,000 data points. So in situations where it's more than 5,000 data points, you want to use something called Kruskal-Wallis, Kolmogorov-Smirnov normality test. So so keep in mind that Kolmogorov-Smirnov normality test is usually used for very large data sets if you want to investigate the normality, but it's also a non-parametric version of the chaperone test. We also have chaperone-Francia, skewness ketosis test for normality, and so on. So this is just a way of testing normality. Keep in mind for normality, your p-value shouldn't be significant, meaning that it shouldn't be what greater than your alpha level in order to conclude that the data is normally distributed. If the p-value is significant for normality, it means the data is not normal. All right. So, and these are visual ways of investigating whether a data is normally distributed using something called quanta plot. So keep in mind that if all the data point lies around the line of best fit, it tells that the data is, even with this clearly. So this is what I meant by this is descriptive summary is by a plot. From here, I cannot conclude that the data is normally distributed. I can only say that it appears to be normally distributed, but I have to do a statistical test, which is an inferential test, in order to conclude that indeed the data was normally distributed. Okay, so keep that in mind, because if you look at it graphically, you realize that at the tails, it wasn't perfect, yeah, and so but statistically or inferentially, the data was normally distributed. That's the bit. All right. So now this is some of the practice that you can do, especially when you want to investigate complex slope graphs. That is looking at change between some variables at different time points, and you want to also stratify it based on some specific variables. So now let me just come down. So it means this is also another graph that I produce. So it's more like we collected data, and after 6 months, I wanted to know the change in the data at the change in the data at 2 different time points. Okay, so so that's that. I was supposed to add some legend here. I forgot. Yeah, but so basically here the green and then let's say the red are basically at different, I mean, the baseline and then the current time point. So it means you see that here, all the data points are at 0, meaning that this is the initial time. And now I want to see up to 6 months or over 6 months, are there increment or decrement across the entire population, capturing individual heterogeneity. And that's basically what I was trying to achieve here. And then these are also other visualization you can do. So it means with this function, you can also explore. Here we are looking at the change at 3 time points. So it means that here you can generally have a idea whether there's increase from baseline to 12 months and whether there was a general decline from 12 months to 24 months. And then he has stratified it based on some treatment arms. Okay, so this is just based on a simulation, but these are kind of graphs you can also produce in your study, especially if they are repeated measures. It could have maybe 5 time points. You could still visualize that. All right, so this brings us to the end of my today's class. So it means that basically on the YouTube channel, I have already covered very in-depth statistical stuff, including everything you need to know, simulations, everything. I mean, and then I did it for people who are beginners to really appreciate it. So just to recap what we've learned today. Today we've really learned. I gave a brief overview about what R and its IDs are. And I said that you can run R in R-base. You can use the R Studio, which is much more preferred over the R-base because it's user-friendly. And we even have an R Markdown, which you can open from R Studio. I will create a whole video on R Markdown in the sense that it is also very useful and it behaves as if you are doing Jupyter Notebook in R Studio. So keep in mind that you can this Jupyter Notebook that you are seeing that I can do a lot of things. You can also do the same thing literally in R Studio using something called the R Markdown. I'll create a video on that. But the Jupyter Notebook is by far is the best RDE you should use for anything you are doing so that you can easily share your results with other people and so on and so forth. And then we introduce some important aspect of data analysis. We covered types of variables. We covered regression models or regression analysis. And we said that the nature of the dependent variable and also the structure of the data, whether it's cross-sectional or longitudinal, would inform the class of regression model you can use. We learned how to import data of different structures, meaning that data from different statistical softwares, whether the data is a CSV data, Excel, whether the data was in SAS, SPSS, or Stata, how do you import them and work and work with it in R? So we learned how to do that. And the most important aspect of today's lesson was how to effectively use ChatGPT for programming or any statistical test you want to do. So it means if you have any statistical query, the first, before you ask anyone, try ChatGPT first, and it will tell you, it will give you fairly correct response. So don't listen to those people saying that they believe that it is no. It's never true. Those who are using it, it depends on how they are using it. But if you are using it for programming, you are 100% assured, because it's AI and programming is AI. So that is why it works so well when you are doing statistical programming, data analysis. You want to know how to do it in any software. ChatGPT will help you. And today I introduced something called slope graph, and slope graph is used for visualizing paired data or data that are repeated measures. So it means that when you collect data at multiple time points, how do you visualize it? So this actually brings us to the end of my session. If you have any questions, I am happy to take them now. The questions could be anything. It could be from your research work you are doing that you think you want some advice on how to go about certain things. It could be questions about what I've taught now. It could be any statistical question, and I'm happy to take them. Thank you very much.
Thank you so much, Dr. Chumesi. We are really grateful. All right, guys. So we will take a few questions, and then we will invite the president to give a presentation to Dr. Chumesi. So a few questions, okay, maybe at most 3 for the sake of time. You can leave your question in the chat box if where you are, you can't unmute yourself, or
okay,
you can ask to unmute yourself and you'll be unmuted to speak. So you just raise your, okay, I think I see 2 hands raised.
Yeah, before the questions, a quick one. So for the YouTube channel, first of all, once you just go to YouTube and you type Clement Chumesi, when you type Clement Chumesi, my name is unique. So it's the first one. You just click on that. But I'm going to paste this at the chat area, but you just have to search for my name, and then you are good to go. So just Clement Chumesi, and that is it. And keep in mind that don't forget to subscribe, and then and there will be lots of interesting videos. So I'm going to paste it at the chats area, and then yeah. So now I can take the questions now.
All right. The first person, Chief, please, you can unmute yourself and ask your question.
All right. Thank you very much, Doc, for your presentation, and God bless you. So my question is, with all that you taught, with someone who is using Mac, right, are they the same procedure? That's number one. And then also,
okay.
Yes. Yeah. So, and also, when you are installing the R, do we, like, I want just to confirm what you said. Do I need to install the R Studio in addition to the R, so that I'll be clear on that? Yeah. So
all right.
That is what.
All right, then let me answer the second bit, and I'll come back to the first bit. So for the second bit, in terms of installation of R, keep in mind that people are using different operating systems. So majority are using Windows, some are using Mac and Linux. So I've specified that the first step is click on this link and download the R base. Okay. So if I click on this link, let me just come there. So you realize that for it has given specific instructions. So those who are using Windows, you go there to download the R base, okay, or the base R. The base R, you will not use it for anything, but in order to install R Studio, the base R must be installed first before you can install the R Studio. Otherwise, you have to use something called Anaconda. For Anaconda, you can install R Studio directly without necessarily installing the R base. Fine. So that's a disclaimer. So for you using Mac, so Mac, this is the specific instruction for Mac users. So all you need to do is to click on this and you can install the RBase. And then there you would be able to also install RStudio. And the RStudio, you see it the same way you saw the RStudio on Windows. It will be the same. Now, what is the difference between programming R in Mac or Linux machines and also for Windows? I think I have to touch on that so that people would be well informed. Now, there are instances where you are doing some complex simulation, okay? And because of that, you are doing something called for loops or iterates or set of iterations. And when you run any code in R or any programming language, it only runs on a single core or a single processor. So if you look at your computers, someone would have a computer with 5 processors. Someone will have a computer with 7 processors. So, but anytime you run a programming language, a code, it is only running on a single processor. So when you're doing, let's say, simulations, where you have to do, let's say, 100,000 simulations, 1 million simulations, and let's say each single iteration takes a lot of time, like the kind of stuff I was doing in my PhD. If you don't parallelize your code, parallelizing means that you set your code to run on multiple cores. But to do that in R, especially when you're using Windows machine, is quite challenging. There's a function called par-l-apply function that we use to do parallelization or setting up your code to run on multiple cores on Windows. But with that, it's quite challenging and it's super slow. But there's a function called mcl-apply, and that particular function, it only works on Linux machines or Mac machines, in that for R, it can only work it can only work on Windows when you specify the number of cores as 1. And basically in that case, instead of the mcl apply, it's just using the l-apply function. You don't need to understand those things for those who don't need this information. But I'm just trying to say that parallelizing your code to run on multiple cores is easy to be done on Mac or Linux machines. And also when you plot graphs, the quality of the resolution on Mac and Linux machines are always much better than on Windows. However, what I just used is Windows, and on Windows too, I showed you, whether Windows or Mac, I showed you a way of setting your resolution so that it doesn't matter the resolution. If I set it as 300, it doesn't matter whether I did it on Mac or on Windows operating system, I should be able to get similar quality. Fine. So in terms of the installation, that link, so I'll share this link with the team, and then I also put it everything on the Piazza. So you remember before the beginning of my session, I indicated that I manage all the YouTube videos you are going to watch, the course, the data I was using, everything. Once you click on this link or you click on the second one, it will take you directly there. And then with that, you'll be able to have access to all the codes that I've been using all this while. So last year, the NUGS-China MasterClass 2022, this is everything that I did under that. So it means for this one too, I'll create a similar session like that where you can download each code and then work with it. But in order to have direct access to this, you need to send me an email. And you need to send me an email for me to enroll you on the class. So it means that how I enroll, so this is, I literally go to manage class, and then, and you don't need to pay anything, everything is free. So when I come down here, I'm able to specify, so at the moment it means over 308 students out of 400 have enrolled. And then I just have to specify your, your email, and then it will send you an automated email for you to enroll. But so the first thing is that you would just have to send me an email, and my email is, I think my email is quite, I have multiple emails, but you can send me emails on, I'll put it on the chat. So c.chimesi@imperial.ac.uk. So basically that's my email. Let me just add it here.
Doc, you could actually leave it with us. We will put everything on the
okay, that's fine. Yeah. So that was the first bit of your question. And so was it the second bit? Has your first question been answered as well? Is it Chief?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
All right then. All right then.
So so it means that if I run the R, I need to also run the R Studio, which will
Okay, so
help me
in order to run R, you install the R base and you install the R Studio, but you'll be using the R Studio for your analysis.
Okay.
And then on the YouTube channel, if you start with the first lesson, you see how to import data. It's like it takes you from basics as a beginner. And then the more you watch the videos, it starts getting complex. Okay, so that's how I set the YouTube channel. And some of the content on my channel, you might not get it anywhere because I use my own programming experience to create those content. Though I've not had time to really like customize and activate for more subscribers. But anyway, so feel free to subscribe, feel free to share with other colleagues, and then there'll be lots of
thank you. Yes. Once again, thank you, Dr. Chumasi, for such an insightful presentation. Yes, so I'm Mr. Francis, the main organizer for Ghana R Research Group. Chumasi is a brother to me. So my question is actually like, I was taking some students through R Studio, like I was taking them through the basics, and one of them asked a question. I really answered the person, but I wasn't satisfied with the way I answered him. So he tried to install a package, and then R Studios told him that the package he was trying to install can be found in another version. So I don't know how. I just had to explain the way I understood it. So I don't know your take when it comes to that.
Yeah. Okay, so but before then, this question goes to the organizer. So regarding the recording, was I the only one who was allowed to record?
No, I was also recorded.
Okay, then that's great, because my recording, I'm sure it will be somewhere else, and
it was being recorded. It was being recorded to the cloud. So the main NUGS-China host was recording it to the cloud. So
okay, that's great.
Yeah, it will be made available.
Okay, that's
once
great.
The class is over.
Sure. All right then. So back to your question. So first of all, when you're installing packages, keep in mind that specific R versions. So we have different versions of R. So we have R 3 point something, 4 point something. Even when you are doing publication, you have to specify the type of version of the software you used in your paper. Fine. Or in your research. Fine. So keep in mind that not every package is compatible with specific packages. Nonetheless, if that is the case, I created a video on how to install packages when you have such issues of incompatibility, or they say that this package cannot be installed in this version of R. So it means you can actually install the package directly from GitHub. Every R package is uploaded on GitHub, and there's a way of installing that directly from GitHub, meaning that you are installing it from like a website rather than within the R CRAN. Okay, so that is one way. And then if you are someone who uses Jupyter Notebook, instead of installing the package within R Studio or something, you can also install it within Anaconda or using the Anaconda prompt. So there are many ways, but installing from GitHub is the easiest, and you can do that in R Studio or any R ID you are using. So keep in mind, not every package would be compatible with specific softwares. So when you install it and you get the error message, then you act accordingly. There are instances where it says that the package cannot be found in that version of R, but it doesn't mean you cannot install that package. You can install it externally using GitHub.
Okay. I hope, Mr. Mensa Francis, your question has been answered. For the sake of time, Doc, I'll quickly want you to check the chat page. Someone asked, Gladys Waku, she asked, hello, Doc, assuming you are analyzing the impact of moderating variable on the relationship between a dependent and independent variable, which model will be advisable? This is a question asked by Gladys Waku.
Yeah, that's interesting. So keep in mind that so far the regression models I've mentioned, the focus is trying to look at a certain fixed effect or a certain variable and how a set of variables and how they predict or influence the outcome. But there are instances where you are more interested in investigating more complex association, especially some variable might be insignificant, but in the presence or absence of another variable, they will be significant. So it means there could be direct or indirect effects and so on and so forth. So the class of models that we use, the first class is you can use hierarchical regression. Okay, so hierarchical regression, but what is known for capturing moderation and mediation is what you call structural equation models. So structural equation model is more like is the main model you will use when you want to investigate moderation and mediation in the regression problem. So that's the easiest answer. But to do the to do the structural equation modeling, which I'm saying you can easily do that in R, or we have other packages, other external software. It's called Amos. You can also do that in there, but you can easily do it in R using a package called Lavane. And for structural equation model, it means it's using path, path analysis and then confirmatory factor analysis together. Okay, so structural equation model is something that we use to investigate those, investigate that. But before you do that, we use something called hierarchical regression to identify potential moderators or mediators before we further confirm. So it means when you are doing the structural equation model, you are now confirming the structure. So it means you have to propose a structure. But the structure, someone can just propose it based on some hypothesis and have a structure, or someone can actually inform it analytically by doing hierarchical regression first, get potential, potential moderators and mediators, and now confirm them using the structural equation model. And how do you do that? So by hierarchical regression, what implies that, let's say you have 3 independent variables, and the 3 independent variables, you want to see how they predict a certain outcome variable. So in terms of hierarchical regression, what we do is that you first of all fit the regression model based on, let's say, the first independent variable. So it means you have a regression model. Then you add the second predictor to it. So it's more like a stepwise regression kind of thing. You add a second predictor to it. The moment you add a second predictor, let's say the first predictor in the model was significant, but after adding a second variable to the model, it caused that significance to either decrease or increase, or it made it insignificant. Then it means there's a potential mediation or moderation going on there. So when you say a variable is a moderator means that it either increases what? The strength of the association, right? It increases the strength of the association between the predictor and then meaning between the dependent variable and the predictor. So a moderator is a certain third-party variable such that in the presence of that variable, either the relationship between a certain independent variable and a dependent variable would either increase in terms of the strength of the association or decrease. But that is moderation. But mediation means that the predictor or the independent variable is only significant through that. It means that if that variable is absent, that the independent variable of interest will not be significant. So in the hierarchical case, the moment you add a second predictor and it causes the first one to be insignificant, then it means the second one you added is likely to what? Is likely to or let's say the first variable was not significant at all. But after adding the second variable, the first variable now became significant. Then it means the second variable is a potential what? Mediator. So it means that you can use hierarchical regression, add your regression model in a hierarchical fashion, and explore the change in the coefficient of determination to check whether the change is significant or not. So you can read more about or check how to do hierarchical regression in R or any software. And that is more like the preliminary analysis you have to do so that you can now have a fair idea of how your structure, the structure or the complex relationship you want to investigate will look like. And then when you are sure of how the complex, like you've identified potential moderators and mediators based on what I've just said, and now you confirm them using what you call the structural equation model. So structural equation model is the easiest answer, but to do that, hierarchical regression can literally solve that problem for you. And then if you don't want to do structural equation model, you can couple hierarchical regression with some mediation test. So there's in SPSS, for instance, and you can do that in R as well. There's a certain mediation test called it's called Anderson. I've forgotten the name, but there's a mediation test, and Anderson-Hayes test. Okay, so it's called Anderson-Hayes test. So it's a test, or the Hayes test basically. So it's a mediation test. So it means after doing your hierarchical regression and identifying those that you think could be potential moderators and mediators based on whether their inclusion cause a certain variable to be significant or not, or whether their inclusion increase the strength of association. If it increases the strength of association, then that variable could be a moderator. But if the first variable was insignificant, but after adding the new one, it caused it to be significant, then it means that new variable you added is a potential mediator. So in that case, you can now investigate whether indeed it's mediating or not. And you can do that also in R as well. Basically, yeah. So that's the answer. I think I've given more than you need, unless you still are not convinced. Are we okay?
All right. Gladys, walk, please. I hope you're okay. Okay, yeah, she says, thank you so much, Doc. I really appreciate the response. Okay, so ladies and gentlemen, we've come to the end of our program. Unfortunately, we have to end our questions here, but like he said, his YouTube channel is available. You could go watch the videos in case you really you didn't really get things in detail. And of course, the video today will also be made available to all who signed up for the course and are on the WeChat platform. And for those that couldn't, for one way or the other, join the WeChat platform, I'm sure the executives of the national executives or the organizers of the program will be able to sort that part out. On that note, I would like to call on the national president, who is in the person of Mr. Stephen Oseapia, to take over the presentation part as well as the vote of thanks. Mr. President, please, you have the platform.
Yes, ma'am. Good evening. Thank you, Queen Girls. Thank you for the wonderful MC duties that you've carried through. The skill-up exercise so far. Yeah, I'm impressed, I'm amazed, and I'm excited that this is how far we've come. Organizing all the skill-up programs together here and there has been an amazing process altogether. And I believe each and every one of us who, one way or the other, have participated in the series of skill-up programs have benefited so much. And we just want to say thank you to the organizers. We appreciate your good efforts always, and for diligently showing yourself. We thank you. NUGS-China celebrates you. All right, Doctor, thank you so much. I admire, I need to applaud your delivery and your expertise on this subject matter. I'm so amazed how your grasp on the subject matter, very impressive. We know that, such people as yourself are gems and to the union, and obviously your time, your effort, your dedication is invaluable. And so we appreciate you. Say thank you, sir. On behalf of the union, I would like to present this citation to you, which reads, Citation of Honor, Clement Chumesi, PhD. So in other words, Dr. Clement Chumesi. Yes, the National Union of Ghana Students, China, sincerely wish to express their profound gratitude to you for availing yourself to impart the entire membership of the union on R-programming during their 2023 Skill-Up MasterClass on May 26th, 2023. The event would not have been a success without your immense support. We deeply appreciate the in-depth knowledge you shared, sacrifice, and timely efforts. R-programming Skill-Up Training 2023. Dr. Clement Chumesi, kindly receive this as a token of our appreciation and acknowledging your good effort towards us. We say thank you so much, sir. We celebrate you and we say thank you. God bless you, sir.
Thank you too.
Thank you. All right. So
Thank you.
again, I want to say thank you. I believe this is going to be the last session for Skill-Up 2022-2023. It has not been announced, but I just want to say thank you to the organizers and all the committee members, the team that have committed themselves, immensely to make sure that these programs and these systems in place always happen for us. We thank you. We celebrate you. We say God bless you. Yeah.
Thank you so much, Mr. President, for giving honor to whom honor is due. And at this moment, Dr. Chumesi deserves so much more than just honoring you with our citation. We just wanted you to know that we really appreciate you. You've been with NUGS-China for quite a while now, and we are so grateful. Like I earlier on said during my introduction, that I've been part of your classes, and this is really not the first time. So thank you so much once more. Thank you. And to everyone that participated today, you joined as a NUGS member and non-NUGS member, we are really grateful for your time that you joined us to make this program a success. Thank you so much. Wherever you are in China, outside China, in the UK, Africa, America, wherever you are, we just want to say thank you. And a word of encouragement to everyone as a student, keep on keeping on. Keep on working on your research, your studies. There is definitely going to be a breakthrough. Good night to everyone. And as I said, the recordings and everything will be made available, especially for those on a WeChat page. Please don't forget to also check out Dr. Chumesi's YouTube channel, all right? Because like he said, details, much details, the nitty-gritty of stuff, you'll find it on his YouTube channel. And if you are somebody who is really interested in using R for your statistical, projects, then you have it right at your doorstep with Dr. Chumesi on his YouTube channel. Thank you guys and have a blessed night. Goodbye.